Hello, welcome to our new unit. Here is Unit 3. It's called Triangles and Congruent Triangle Proofwriting. So by the end of this unit, we're going to be writing what's called a math essay, which is called a proof. You're given some kind of introduction or given information, and you have to make an argument to prove a special statement or topic. Okay? This very first page I want you to do on your own. It's the warm-up. There's a little riddle here. So the directions read, please try the question in part 1 and part 2 and put the corresponding letter in the riddle below. You may assume that any small angle is acute and a larger angle is obtuse for this first section. So just kind of looking at picture number 1, when two sides of a triangle are equal, it's isosceles. So 9 centimeters, 9 centimeters, 8 centimeters tells us that the triangle is isosceles. So we have isosceles here, here, and here. But these angles appear small. So that's going to be an acute isosceles triangle. So that's letter I, and that was question number 1. So wherever there's a 1, we're going to have an I. All right. Down here, just some directions. If the answer has a closed box next to it, like an angle of 116, whatever number that corresponds to up here, 7 through 12, you're going to cross out that box, okay? So you're just going to shade in the box containing that exercise number, okay? So try what you can on this front page, upload it. If you need to watch the notes first and then come back to this at the end, please do. But starting in our notes. So here we are going to classify triangles based on their sides, okay? So there's 3 names: scalene triangles, isosceles, equilateral. You've heard these words before. We're just going to review them. So the sketch of a scalene triangle is a triangle with 1, 2, 3 sides, and none of those sides are equal. So scalene triangles have 0 equal sides. Okay? The measurement here might be 2 centimeters. This measurement might be 8 centimeters. And this side might be 9 centimeters. But either way, none of those sides are equal to each other. It's also going to have no equal angle measures. So this angle is larger than the other 2 angles because those 2 sides have to open wider to get to the longer side opposite it. So within this unit, we're going to be talking about the relationship between an angle and its opposite side. Isosceles triangles are triangles that have 2 sides that are equal. So it has 2 equal sides. Okay. A couple vocabulary words with your isosceles triangle. This angle up top, where the 2 sides meet, is called the vertex angle. And these 2 bottom angles here, kind of like the feet, if we were thinking about 2 legs, okay? Because to be honest, these 2 sides are called the legs. The legs are the equal sides, okay? And down at the bottom, you have what's called the base angles. Couple notations. If I call this triangle DEF, D bottom left, E up top, and F over here. A little notation is that DE as a segment, this side, is always congruent to EF. And something about these angles, base angles, are equal in their measure. So the angle D is going to be congruent or equal to that angle F. So whatever this measure is, this would be the same. And if I were to use a protractor, sorry, I'm opening my drawer to see if I have one. So what I can do is I can use this protractor to kind of estimate how big this angle at D is. So I lined up the protractor center to the middle, and I would estimate that angle to be between 60 and 70 degrees. I can see the little markings for here. If I slide that in so you can read it. So that angle is going to be about 65 degrees. Well, if that angle is 65, F is going to be 65, all right? And we know that in this fancy calculator here, all three angles add to 180. So if I take 180 and subtract the two angles of each 65, we find that the third angle, that vertex angle up top here, angle E, is going to be 50. So a little reminder is that all angles in a triangle equal 180 degrees. And that's going to come up again on the back of this assignment, okay? But I just wanted to talk about the isosceles triangle. We're going to focus on that a good amount in this unit. The last shape is an equilateral triangle. Another name for equilateral is equiangular. Lots of vowels all together there. E-Q-U-I-A-N-G-U-L-A-R, equiangular. What that means is equal angles, okay? So an equilateral triangle is also equal angles. So if I have an equilateral triangle, has all three sides being the same. So if this one was 10 inches, this length is 10 inches, this length is 10 inches, its perimeter would be 30. Remember, it's the sum of all sides. And its angles being equiangular. If I have 180 degrees and I know all three of these angles are the same, when we divide by 3, we find that each one is 60 degrees. So all equilateral triangles will have 60-degree angles for each one. Okay. If I were to tell you the most important thing about every question you're going to have on your classwork for this unit, it's going to be this statement right here. Okay, be sure to draw a diagram for each example. There's words. It's talking about a picture. This is a very visual class. I've drawn 3 triangles so far. Yes, there's a lot of words and symbols going with them. The same case is going to go here. If triangle ABC has a perimeter of 51, we're going to draw a triangle. P equals 51. I'm going to put that inside. And it's triangle ABC. So it doesn't matter where you put the letters, as long as you put them around the shape. A to B, however long it is from here to here, is a measure of 4 times x. B to C is twice the value of x, add 1. And C to A is 6 times the value of x minus 10. Find each side of the triangle and classify based on its sides. So remember, perimeter is the sum of sides. And we did that a little bit with the distance formula back in our first unit. And we're going to come back to that here as well in the next few pages. So these 3 sides are going to add to the whole perimeter that they gave us, 51. So we have 4x added to 2x plus 1 plus 6x minus 10 equals 51. This is a good moment to pause the video. Try solving this on your own. Combining like terms, we have 6x and 6 more x. Remember, it's 12 x's altogether. 1 minus 10 on the same side, we have a sum, is negative 9 equals 51. When we add 9 to both sides, 12x is 60, making x 5. Now we're not done with the question, okay? So what we have to do is always reread back through what they've asked us for. Did that ask us to find the value of x? No, we needed it though, so we can find each side of the triangle and classify it based on its sides. So sometimes when you substitute a value in, this one and this one might be the same measure, therefore it'd be isosceles. Or if you sub a value of x back in and they all end up being equal, it would be equilateral. So AB, remember, is 4 times x, or 4 times 5 would be 20. BC is 2 times 5, add 1 is going to be 11. And AC, and again, I'm going right back to these expressions, is 6 times 5 minus 10. Well, that's 30 minus 10 is 20, okay? A little check here. Do those add to 51? They do. But now, looking at those 3 measures, they were 3 different expressions. So some of you would have assumed, oh, it's scalene, they're all different. But when we sub that x back in, we find that 2 of them are the same. So after subbing back in, we can confidently say that this triangle is isosceles, okay? So to classify it based on its sides, that triangle would be isosceles. So again, perimeter is the sum of the sides. We made a whole equation to equal to 51. Example 2. Given equilateral triangle RST, find the length of each side. Well, knowing it's equilateral, we know that this side equals this side equals this side. Now, we can only make an equation by setting two things equal at a time. So we know that RS equals ST. So if RS is x plus 9, we're going to put that in for RS. If ST is the 2x, we're going to put that in for ST. So again, we can only set two things equal at a time. I know all three pieces are the same. Doesn't matter which two we would choose here. But now when we solve for x, we subtract x from both sides, and 9 equals x. Okay. Now find the length of each side. We can sub that back in. Well, 9 plus 9 gives us, this side is 18. 2 times 9 gives us 18. And 3 times 9 is 27 minus 9 is 18. So to check that all three sides, sorry, I'm kind of scooching my paper back and forth as I'm writing on it, are the same. Example 3. Triangle LMN is an isosceles triangle. So again, we're thinking the sides here with LM equal to LN. So as I draw a picture, I'm going to make it look isosceles. Here I know the triangle is isosceles. Back up in exercise 1, we didn't know that on the beginning of the question. After finding our x value and subbing back in, we found the two sides to be equal. So when I'm sketching my pictures, sometimes you're going to sketch one that might look equilateral. You can't take your diagrams for the truth until you solve out the question, okay? So that triangle looks like equilateral because it's just how I sketched it to draw my picture to help myself with the question. Here, they're telling us it's isosceles, so I'm making it look isosceles. Now, looking at what pieces are equal, it's going to make a difference where the letters go. LM equals LN. So what that tells me is L, that letter that repeated here, is the top. So that L to M and L down to N are going to be the equal sides. So again, side measurements from L to M, this length here is 3 times an x value minus 2. L to N is 2x plus 1. And then they gave us the third side is 5x minus 2. Now some of you say, oh, there's 3 things. I'm going to add these 3 things up to equal 180. Okay? Wrong. These are not angles. Way back up at the top of the sheet, I said here, all angles add to 180. But this side of the paper, we're talking about their side measurements. Sides add to a perimeter, not 180. So they have to be telling you that measurement all the way around. Or here we're going to find the measure of each side and find the perimeter at the end. So a couple pieces of important information is that these two parts are equal. So this expression, the 3x plus 2, which is LM, and LN is the 2x plus 1, those things are equal. So rewriting that, this side and this side are the equal pieces. So since LM equals LN, 3x minus 2 equals 2x plus 1. This 5x plus 2 is kind of extra information at the moment. We need it when we go find the perimeter in a minute, but we're not going to use all this information to set up our equation here to solve. Okay. So solving for x, remember move your x terms over first. So 3 minus 2x's is x minus 2 equals 1. Add 2 to both sides, x equals 3. Right? Now, knowing x is 3, we need to find LM, LN, and MN. We need to find the length of each side, and then we'll add those together to find the perimeter. So LM is 3x minus 2. So it's going to be 3 times 3 minus 2 is 9 minus 2 is 7. LN is 2 times 3 plus 1. So 2x plus 1, and since x is 3, I sub that in, gives me 7. Well, those should be equal because those were equal sides. So we're okay so far. And the last side is 5 times 3 minus 2. Gives us 15 minus 2 is 13. So adding those sides up, 7 plus 7 plus 13 is 14 plus 13 gives me a perimeter of 27. Okay. So again, this whole side here all was classifying triangles based on their sides. So one example, we were given expressions in a perimeter. We found that the triangle was isosceles, right? With AB and AC being the equal sides. So this one and this one ended up being equal. Example 2, they told us it was equilateral. So we added up all three, or we set 2 sides equal at a time. We can't set more than that equal. Example 3, they told us it was isosceles. We found its perimeter. So those are our first 3 questions dealing with the sides of a triangle. The next page is classifying triangles based on their angles. So we have acute triangles where all the angles are teeny tiny. Okay. So here's a nice little triangle. This angle, and this angle might be all different measures. So this kind of notation tells you that all 3 angles are unequal. If this angle is 50, this angle might be a little bit bigger, let's say 70. Well, if I know 2 angles, I could find the third. So remember, 180, subtract 50, subtract 70, gives us that the third angle is 60 degrees. So acute triangles have all angles less than 90 degrees. So I'm using our inequality symbol there. So when I talk about the angle symbol, I use that little arc mark. That's the symbol for angle. This symbol means the word less than, where, remember, this is your symbol for greater than. So you might wonder why I put this little curve in there. That's just to kind of change from one notation to the other. So here, all angles are smaller than 90. Now, since all 3 of these angles are of different measure, this is acute, and this will also be scalene. Because if this angle is 50, that means the side opposite it is a different measure than opposite the 60-degree angle than opposite the 70. So no equal angles means no equal sides. So no equal angles has no equal sides. Now I could have an isosceles triangle with all small angles. So if this was 30 degrees, well, 180 minus 30 gives me 150. And for isosceles, these have to be equal. So if I take 180, subtract 30, you get 150, and divide that by 2, each of these base angles would be 75 degrees. Now, are all of those angles smaller than 90? Yeah. So you could have an isosceles triangle that's also acute. Right triangles have a right angle. Right? One right angle, and remember, right angles measure 90 degrees. Now, can you have 2 angles of 90 degrees in a triangle? Well, could this angle and this angle be 90 degrees? where all three add to 180? No. These two angles are called complements. So angle A here and angle B have to add to 90 if we have one 90-degree angle. So one of them can't be 90 degrees and the other be 0, because you can't have a 0-degree angle and make a triangle. Okay. Now, if I were to mark that these two sides were equal, then now this is an isosceles right triangle. Well, if A and B are the base angles there, so sometimes you might have to rotate your pictures around to see that it's isosceles. And we're going to come back to an isosceles right triangle later when we do what's called special right triangles. But when you have a right triangle with two equal sides, these two angles are half a 90. So 90 divided by 2 is 45 degrees for each of those angles. So when you have an isosceles right triangle, okay, your other two angles are each 45 and 45, so that all three, with 2 being equal, and the third one add to 180. Okay. Obtuse triangle has one angle larger than 90. So one angle in that shape is bigger than 90. So let's say that this angle is 100. If this was 20, this had to be 60. So talking angle measures there, again, they all have to add to 180. But if this angle measured about 100 degrees, again, I'm making some of these measures up in my head as I go for explanations. All right, then these two angles could be 20 and 60, could be 30 and 50. We don't know, but that's a possible option. So this would be an obtuse triangle. Important piece here is neither of these angles could be more than 90 as well, because 100 plus something bigger than 90, like 91, adds to too much. It adds to 191. So then the angles would be more than 180. So that's just a couple key pieces of information. Remember that all angles of a triangle add to 180. Okay. This first part of the sentence is important here. Example 4, if it's not drawn to scale, use the given information. Most of the sketches you're going to have are not going to be drawn to scale. So you have to really use the information from the pictures. Classify the triangle based on its angles and sides. Okay, so we're going to add in both information here from the front page and from this page here. So right now I know two of the triangles. So we're going to take 180, subtract 60, subtract 28. So 180, subtract 60, subtract 28 gives me that the third angle in that picture is 92. So that means the last measure there, X, is 92 degrees. So now that we have all three angle measures, we know one of the angles is larger than 90. So this triangle is obtuse. And so that's based on these angles. And since none of those angles are the same measure, this is also going to be a scalene triangle. So again, when no angles are equal, no sides are equal, makes it scalene. Okay. Example 5. Given the measures of two angles in a triangle are 50 and 70, how could you classify the triangle based on its angles and sides? So again, I'm just drawing a random sketch. I can't make any assumptions based on this picture until I put the measures in. So if one triangle is 50, the other triangle is 70, well, 180 minus 50 minus 70 gives us our third angle is 60 degrees. Well, none of those angles are the same, so this must be scalene. And none of those angles are equal. So, all of these angles are less than 90. So this is scalene and acute. Now these topics most of you remember from middle school. I'm just going over some easy examples here. Okay. Example 6 talks about an isosceles triangle. So I'm going to start my sketch looking isosceles with 2 equal sides. And something else we know about the isosceles triangle is it has 2 equal base angles. Okay. So the vertex angle of an isosceles triangle is 3 times the measure of each base angle. So remember, with these word problems, each base angle is your value of x. Okay, so x is going to be our base angle, x there and x here. Then the vertex angle of an isosceles triangle is 3 times that measure. So that's going to be 3x. All right. So whatever the one base angle is x. I need an x next to the other base angle because those are always equal. The vertex is 3x. So combining like terms, 3x plus x is 5x's. Add to 180. So again, I added my 3 angles together there. You always need 3 things to add up when we're talking angle measures. Divide by 5, and 180 divided by 5 gives us 36. So that tells us that if I were to resketch my picture, each base angle is 36 degrees, and 3 times 36 gives us that the vertex angle is 108 degrees. Okay. So 3 times 36 gives us 108. So here they asked, what are the measures of all 3 angles? 36, 108, and 36. Classify it based on its angles. This is an obtuse isosceles triangle. Okay, so that's the end here for our first page of notes. Again, what we've asked you to be working on for part of your classwork credit today is the warm-up to the assignment. Okay. If you'd like to do this in Kami, you can. If you're working from home today, you haven't gotten this packet yet. I apologize. With it not being in classes the last couple weeks, it's been a little chaotic. But this classwork, all right, 301 is also part of your grade today. So we'd like you to try the warm-up. Should be a little fun. And this classwork assignment, 301. Please try the following questions. Draw on the diagrams given to help answer the question. So here we're talking about angles. Here we're talking about angles. Okay. Angles add to 180. Remember, all 3 angles in a triangle add to 180 degrees. However, when you get to question number 4, you have to be careful. Question number 4. Remember that sides, so here you're given 3 expressions, okay? But they also give you the perimeter. Remember that sides do not add to 180 degrees, okay? That's an important fact that we need to remember. Sides do not add to 180. So given side lengths are these 3 pieces, those are going to add to your perimeter. That's like questions 1 and 2 on the notes. Okay. Same thing here with number 6. It's an equilateral triangle. So I'm going to say C number 2 in notes. All right. This very last question, number 7, I do want to help you set up. Okay. Given triangle ABC, measure of angle A is x squared plus 65. The measure of angle B is 10x plus 70. The measure of angle C is 21 minus 5x. Okay. Now, we don't know which one's the bigger one or smaller one, but if I just look at this picture, one angle is x squared plus 65. Another angle is 10x plus 70. The third angle is 21 minus 5x. Those are angle measures. So remember that angle A plus angle B plus angle C adds to 180 degrees, meaning x squared plus 65 adds to 10x plus 70 adds to 21 minus 5x to equal 180 degrees. You do need to combine like terms, and at some point you're going to have to subtract that 180 over, okay? So remember to try to keep your equation into the x squared plus something x plus something equals 0 format. Now I'm putting that in pencil because I don't want you to write that necessarily right now. But remember, you need to have the x squared term first, the x term here, and a number at the end. You always multiply to this number and have to add to whatever's here in front of x. Right? So that should help. If you have any questions or need anything more, please send me an email. Thank you.